we have seen a system with distributed databases. So there was not one single database, but there was a number of databases. And what we did is to extract rules from one database and place it in a layer on the top of the database called a knowledge base. And if we received a query at one system that could not resolve the query, then we could extract definitions from a remote database and replace the attributes which the current database does not have with their definitions that were extracted from remote site. So we have seen this distributed scenario. So today we will look at a different architecture for distributed data analysis. So we will look at cloud tools. So cloud tools such as Hadoop, for example, would allow us to run our data analysis not on a single machine but on several machines at the same time in parallel. So that is what we would call a distributed data analysis. And so we will look at some definition of what is Hadoop, and we will look at the distributed file system for Hadoop, and then some basic sub-projects of Hadoop. So we will also look at the MapReduce programming model and related projects such as Peak, that is its separate programming language, HBase, for storing data sets on a clustered environment, and Hive is a similar system to that you can issue queries similar to the queries we did last time in SQL form, but they will be on the cloud system. So what is this Hadoop and why do we need it? Sometimes, so if we might have a huge data set, like for example, the data sets we have been using in this class for data mining are regular data sets, but sometimes, and the algorithms that we run on them can run on probably your laptop without a problem, but sometimes if we have a huge data set, the algorithms that we discussed might take a very long time to run on your laptop or even on a bigger server. And so for that reason, what the scientists came up with is the idea to split the data set into several pieces and have each one run on a separate machine, and finally try to combine the results together to report the results of the analysis. So unfortunately, this type of system, which is composed of several nodes, so a node will be a computer that's connected to the rest of the computers via a network. These type of nodes, they are everyday commodity machines. There are cheap, inexpensive computers that are just connected together, and any of those can fail at any time for that reason. So with Hadoop, the idea is to expect the failure to happen and prepare for that. So we are expecting failure, and at any time, the number of machines that are connected to the cluster might change, and some of the machines may no longer be available. So we need a common infrastructure that is easy to use, that will provide reliability and is efficient, and that is what the Hadoop is. So the Hadoop is a batching program that allows this type of several computers to be connected together and work together in a clustered fashion. Who is using this kind of system? There is a number of organizations out there that need to use it because of the amounts of data that they need to process. So, for example, Amazon is using that. I don't know if you have seen the Amazon Web Services. They have made their clusters even available to people who want to use them for projects, and you could go out there and rent their servers at any time for time that is used, they will charge for that. Facebook has to use it because of the amounts of data that they have, and Google is also using it for searching web and building its indexes and its page ranking. And then other things like publishers, New York Times, other search engines, and many more are using this system. So how does the system look like? As I mentioned earlier, there is a bunch of machines that are commodity machines that are inexpensive, everyday personal computers in a sense, PCs. And this is called a node. And a node has a number of hard drives, disks that it has. And these kind of nodes are connected to what is called a rack. And so the rack will have several nodes in it. So the rack is pretty much like a networking switch where you would plug in the network cables and connect these machines together. So in a rack there could be several nodes, and finally these racks are connected to a higher level, which means a faster network switch, called an aggregation switch. So the red lines are the ones that are the higher level network or faster. This is 8 gigabit, and the green lines are 1 gigabit. So there's a two-level architecture. And there could be 30 to 40 nodes per rack. And as we mentioned, the rack speed is 1 gigabit, and the uplink from the rack is 3 to 4 gigabits per second speed. So how are these machines connected? How can we store our data set on several machines and make it look like to the user that they are sitting on a single machine? Well, how is data stored on a single machine to begin with? There is a hard drive and there is a file system. So the file system is what the operating system is using to maintain the files on the system. So there is a directory tree, there are files inside the directories. We have the same situation, except this file system is called a distributed file system because it is stored on, the file is not stored in one place, but in several places, and it can end up anywhere in the network on any of the hard drives. So, distributed file system, there could be many nodes. There could be 10,000 nodes, there could be 100 million files. Obviously that system is much larger than the one on your laptop. Again, we are assuming any of the machines can fail at any time, and for that reason, the files we keep several copies of them. So it is not just one file in one place, but we will take the file and make 3 copies and store it in several different places for just in case any of the machines are died or crashed at any time. So the Hadoop system itself, the distributed file system, will detect these failures, and if one of the nodes failed and then all the files are lost, then it will recover or get a copy from another node. This type of system is built for the purpose of batch processing. So Hadoop is a batch processing system, which means send your job in a queue and wait for your job to be done. And when your time comes, your job will run. And then the next job will run, and then the next job will run. That's called batch processing. So the data locations are exposed so that computations can move to where the data resides. As a whole, the system should be running in acceptable or reasonable speeds. We have seen the speed of network was 8 gigabit and the high level is 1 gigabit in between the nodes. Of course, there is a network, and if the data is going to be sent through the network from one machine to another, it will take longer time than if the data was on your laptop and it doesn't have to go anywhere and you're just accessing the hard drive directly. So the more data we have to send in between the nodes, the slower the performance of this cluster. So there is, the way that it works is that there's a namespace for the entire system. The model is writes the file once, and we expect that this file will be accessed many times. The way the files are stored is the same as your regular file system on the laptop. The files are divided into pieces called blocks, and depending on the size of the block, typically size of block on your laptop is much smaller than that. And the reason is because if your file, if average file is not 64 megabytes, then the rest of the block will remain empty and it will not be used. So we must really have very large files in order to make the block size 64 megabytes and not waste the hard drive space in this way. So this block is much larger than your regular file block on most operating systems. Each block is replicated on multiple data nodes. As I mentioned, the file, we can see copies of it, but not just the file, but all the blocks of the file. So the file could be huge, it could take up more than one block. Each block is stored 3 times. Intelligent client, the client can find location of all the blocks. So this main namespace knows where each block resides, but the client can find location of all the blocks for a particular file, and it can access the data directly from the data node.